There we go. All right, so David sent a couple pictures. I got a couple questions I'll go through here in a second. So give me 1 sec. Let's wait on that one, David, and I'll do it in a few minutes. We'll get through this. So first things first. Brock, are you back? Are you here? Are you watching? I need to make sure he sees it. Yes, perfect. All right, so right here is your part file. Now, I just want to show you my part file, and I want to point out one thing. When I have my stock on, and I look at my origin, mine's top dead center. Yours is right over here. So that's what you'll see. Your machine setup is right there, which is totally fine. The adjustment we have to make is on the toolpath pattern. When we're on here, mine is going off the origin of the part, and the origin for my part is the center of the part. So it's XYZ0. Yours, what we're going to do is just hover over this arc in the middle, then pick that center point. And what you'll see the difference is you have a Y that shifts your rotation center point up 3 inches to the center of the part. And then if I hit OK, it fixes it all. So that was the only difference, and which is totally fine. That might be where you set your origin up. If that's not where you wanted to set your origin up, you'd have to go right-click on Machine Setup 1 and say Edit, and then you'd have to pick this top dead center point here. Now, I'm going to do this. If you meant to do it, that's great. If not, we'll fix it here. Now, for everyone else who's seeing this, think of this as if you accidentally put your origin in the wrong place when you started and then you made all your tool paths, which happens. I've done it a bunch of times. Or it's one of those things you're thinking, I'm going to use the bottom left corner. And then when you get it set up on the machine, you realize it's easier to find a different corner or whatever. So if I move this, right now, all of the tool path that's in the part is in accordance to where the original origin was. So now that we've moved it, you'll see the tool paths moved along with it. So what we have to do is we have to right click on milling job and then just do update all geometries. And then we're going to right click on milling job again and then hit compute. And it should just recalculate all those bits of code. All right. And now, because we have our toolpath pattern, the toolpath pattern now has to relearn the position, or we just have to reset it. Right now, what's happening is it's rotating it about a center point right out here. And from our one toolpath, it's just basically spinning around itself. So we just have to edit that, just have to edit that toolpath pattern and just say pick. And once again, just pick the center of your geometry. You don't have to worry about Z because it's the center of the geometry. It's for X and Y. So now I can hit OK, and that's going to set it up. Now, the next thing I always would say, if you do make this mistake, go in and check the holes afterwards. Open up, especially your tapped ones, open up your feature because it likes to do this shift of the top of the part. And we went with Brock's copy. He had his origin on the bottom of the part, which is common for if you're doing this on like a spoil board where you'd be setting your part down and either vacuuming it down or clamping it down somehow, screwing it down, whatever. You'd go off the spoil board and then your heights are up from there. So we'd have to go in and say, well, the top, we'd say pick top. And then this always does this. All right. And then pick just any edge that represents the top. And then right here, we have to reset that depth. So we'll go 1.2, just like that. And then when you go back and look, your parameters should update for your drills and everything like that. So now I can compute that. That's really the only one you'll have to worry about the depths on. And a lot of it comes from the fact that we're using wireframe geometry to define our holes. If we had a solid model and we picked the inner surfaces of the solid model holes, then when we say reselect geometry, it reads the diameter and the depth from that. So the odds of it not making a mistake doing it that way are better. But you'll always have to double check the holes, just because especially when the origin changes Z positions, it can act kind of weird. So there we go. All right, Brock, did you get all that? It was your origin was in a different spot. That's all it was. All right. Awesome. All right, so Brock's got that. Now let me get rid of this. Just got to clean up the chat so I can see which one I'm on. Sent you the file. Got it. All right. So, got it. All right, so John, you asked, can you explain how to look at the views top, bottom, and apply dimensions to them? Yes, we could totally talk about that. So, let me grab this right here. All right, so I have my stock turned on. Let me hide all that stuff. Hide that. There we go. So the top view is this view right here. It's just when you click this button. Now, this is the top view of the top UCS. And the UCS is really what we're talking about if we were to try and dimension in kind of different views. And I'll show you an example of that. So the top view dimensioning is really just whatever kind of dimensions you want to put on your part. I would usually do it. I mean, you're going to use the evaluate tab. And ever since they added this auto command, that's pretty much what I use. So with dimensioning in a top view, which is your standard view, but what the difference is going to be, if I'm in a top view, I'm dimensioning the top. A top UCS. If I was to go to a front UCS, that's looking at the part from a front view. So we're going to go right here and view front. And so all you're going to see is a line. And this is normal because we don't have any, the pockets aren't showing. We don't have a solid model to even like get a cross section of or whatever. So the front view is going to allow you to measure, I'd be able to measure the diameter of our part from like here over to here. And it's going to tell me that it's 6 inches. All right, now I'll hit OK and cancel. And then I'll go back to a top view. And so you'd be able to take your measurements based on whatever UCS you're in. So this, basically the UCS just rotates where you're drawing. So for dimensioning, it just rotates where you're dimensioning. In a part like this, you'd never dimension with that dimension. You dimension everything from the top plane. And basically you just want to align your X and Y axis with your part and then lay down dimensions. For something like this, I would... a lot of this is arcs, so I can pick this arc out here, and it'll tell me what the radius is. So I could do that. If I want to get the diameter, I could pick, let me clear out the geometry. If I wanted to get the diameter of that, I'd pick across those 2 points and get my diameter. Any arcs, you just have to click on the arc, and it'll give you the radius from the center point to that arc. If you want it to show the diameter, you really would have to measure across it like I did with the 6 right there. But fillets, you just click on the fillet. Again, I'm under just the auto dimension here. You just click on the fillet right there. You can see there's a decimal section. You could go out as many places as you want. For something like this, it's an 1/8 inch. So I would at least go 3 on there and then lay it down. For holes, you just pick the hole and it will define the diameter of the hole. I'll go right there with that. Same thing with holes. I don't really have any lines on here. Oh, I do. Here, if you want to measure like a line, you could just click the full line and then you can drag it whichever direction you want to take the measurement for. So lines do have some play with them that you can do. You could even dimension points. So you're just really laying down dimensions. BobCAD is not my first choice in making dimensions and doing like a print. It's possible, but you really have to, like with SolidWorks, to make a drawing, you bring your solid model in, and then you take your solid model and you say, I want to make a drawing out of this, and it brings in the views. You just say, I want a top, front, side, whatever. And it kind of does it automatically. For BobCAD, you'd have to draw that all out. And the way I would do it would be with I would still do it with a solid model, but I would copy and basically copy and paste that solid model. I'd have to rotate it, and it's a bit more work. It's definitely doable, but it can be a lot of work. So, did that answer your question, John? I could go maybe a little deeper. I just need to know where you want to be. All right. Well, he's answering that. So David sent me an email. He's got some parts he's working on. He doesn't have BobArt, which is unfortunate. It's a fun little program to use. And the parts are for a radiator grill spar from a 1934 Cadillac. I like it. All right, so I saved some pictures of it. Let me open these up. All right, so give it a second and it'll open. So this is a part with a little with a ruler, something next to it, and take some measurements. And he's asking kind of any ideas on how to do that. So BobArt would be a good idea, but really I would probably go with a known size piece of graph paper. What are you doing? You're trying to dimension a 3D file, John? Yeah, if it's 3D, you'll have to use those UCSs to get your different dimensions. So yeah, I mean, you could use a piece of graph paper, especially he said the tolerance isn't super critical. And then basically transfer those points that you come up with into BobCAD. It would be tough. I've actually done that method with a gasket that I was working on. I was working with a customer who was doing a stamp, essentially. Just needed to make a little stamp. They make these gaskets every couple years for one company for some snow equipment. And so they needed every once in a while. He didn't feel like making them anymore, so he was just making a stamp for them to make their own. But he didn't have any he just knew the shape of it. So what we had him do is I had him mail me the stamp or mail me the gasket, and then I got a piece of I think it was 1/4 inch divided square paper, graph paper, and then I just traced it with a real fine tipped pen and plugged it in, and then we were able to use that geometry. I brought it in, I drew everything out, cleaned everything up, and then we cut a stamp with we just basically used a V-bit and had it come to a point. And then, yeah, it was a big steel gasket punch, essentially, that the way he ended up working it out is he got it hardened. They set it on a gasket, smack it with a hammer, and that was as easy as they needed to go. It was quick and easy. I mean, for the longest time, they were just cutting a gasket by hand, but this is, it was a bit easier, but that's how we did it. Or another very easy way, but it would cost a little bit of money. It'd be the BobArt. I know you said that in your email, but BobArt would allow you to take this, and what's really nice is you can have a scaled drawing because a piece of paper is 8.5 by 11. So you could put it on a nice, clean white sheet of paper. Again, get a fine-tooth pen or a real thick, heavy Sharpie, and you just trace around it real clean. And then you'd be able to scale that, or you'd be able to scan that drawing in. And because it's on an 8.5 by 11, it has a size. It's to the right scale. And I've actually done that a couple of times with a few companies that are just, the one of them was just trying to create storage boxes out of foam to put nuts and bolts in for a whole kit that they sell. So they were just milling out pockets that fit the shape of the parts that needed to go in there. But the kid that got stuck doing it wasn't part of engineering. He was just some shipping kid. And so they didn't let him have any of the drawings. They wouldn't give him the drawings of the parts to pull the wireframe from. So he was literally just any part that fit on a sheet of paper, we'd set it down, trace around it, and then BobArt it and knock those toolpaths out. So that would be a good one. That would be a great one for something like that. But otherwise, graph paper and then plot out points. And then this whole edge, unless that's kind of like an oval, like if you were to take another one and pair it up to the other side, would it make an oval? You know, if you flip-flopped it and mirrored it, would it oval? That could work too. If it was one big oval that just had two cuts in it, that gave you two of those. But it's different sizes, isn't it? Or are they all the same? Oh, here's the other pictures. You guys can see what it goes on. How do you go to the next picture? There we go. That's what it goes on. So they are all the same size. And so they're the ones down there. Okay. Yeah, I mean, any of those ways would work. But yeah, I mean, if we want to try it just to see if the Bob Art idea would work, can you adjust the spline to adjust? Adjusting splines is I think it's possible, but it's not super. Let's see. So we'll make like a smooth curve, as smooth as I'm getting right now. All right, so there it is. There's my spline. Now, adjusting splines is a bit difficult because normally what you'd adjust with would be like the deform, or really the deform is what you'd get. And I don't know. Yeah, I guess you can adjust it. It just depends on where you click on it. And it affects kind of all the points around it. So it's not just affecting one point. It would affect kind of all the points around it. But yeah, you could definitely drag it and move things. So it's definitely something you could do. You know, I would almost look at putting two of them together, because if there's two of them together and you could get a full oval, you could just do an ellipse. Like if two of those put together made an ellipse, you would measure the X, you'd measure the Y, and all you'd have to do is punch those in. So looking at the picture again, let me open this up. You know, looking at that, if that was to come around and keep sweeping, let's call it 5 and, what is that? 5 and 16/64 ish. What's that break down to? 5 1/4. All right, so we'll go 5 1/4 on the, well, that would be our minor axis, so 5.25. And so that would be the minor, and then the major would be almost, yeah, if it looks like an oval, I would take a measurement of it straight across. Now, he said he did put the two together and it looks like an oval. I would do two straight across right now. If it's 10 inches or whatever, that would be kind of your oval right there. And that might work decently well. And then from there, you could either break it into arcs, or when you create an ellipse, you create a spline. So, I mean, you'd have to figure out your break point, where you want to cut it and where you want to cut it. But other than that, you'd be able to go in and do your deform and modify it as needed. All right. Cool. Yeah, that's probably how they made it. They probably made oval pieces and then cut them. They had a little thing, because you get, you know, two parts out of one oval. Or they just did it one at a time. I don't know. All right, so back to here. Did I answer everyone's question? Let's see. All right, so David, I got you. Yeah, that should work. I mean, it depends on your tolerances. John, I helped you. All right, cool. So I think I got everyone. If you guys have any questions, feel free to throw them in. This is a good one. All right, so did we finish this? Yes, we finished this whole thing. So I'm going to simulate it real quick. I think, did we simulate it at the end of the? I can't remember. I'm just kidding. I remember. We totally did it. All right. So we'll run through this pretty quick. All right. Part looks good. So now what I want to go and do is the pockets. I want to face it. I want to do the pockets, and I want to do the counterbore on the other side. So it's the same. I know a lot of guys struggle with this. It is kind of a goofy one, and we do have to be pretty accurate with this because the holes are not. Yeah, the holes in the center. We need to make sure everything lines up. I guess we're not drilling the hole, so it shouldn't matter too much. So the big thing to do here is, well, first we're going to add our new machine setup. We're going to add another machine setup to the job. And we're going to do that just by right-clicking on milling job here. Excuse me. And then we're going to go down to add setup. 1 second, guys. I got to take a drink. All right. So we've added machine setup 2 in. And the big thing here is we're going to flip the part over. The stock that we have is already fine. We're going to use that same stock. We're going to copy and paste all the tool paths. But we have to make sure, especially if we were, not that we would, but if we needed to drill the holes in that specific location and everything, we just need to make sure that when we flip our part over, we, at the machine later on, flip it the same way, especially with that hole pattern being off. Because if I rotate across the y-axis, the hole switches spots. So it's just knowing which way you did it. Really, it's not that important. For us right now, we're just going to grab it. I'm going to go over the x-axis. So I'm going to flip it this way. All right. Or if we go control, there's a bottom view on here. How does the bottom view do it? So yeah, so we could basically just go to a bottom view, and that's going to be exactly what we want. So it's just click that drop down and then that button right there, or it's Control 4. So Control and the number 4 above your keyboard will give you that bottom view. And then from there, I'm also going to tweak it a little bit so that it's like this. Remember, you can rotate just by clicking that middle mouse wheel in. You do not have to use the buttons up top. Just click your middle mouse wheel like a button, hold it down, and move your mouse. It'll save you a lot of time. So I'm basically setting up the stock, doing the machine setup again. So we're going to try it. Or we're going to do it. This isn't a try. This is easy. All right. So we first have to, we've defined machine setup 1. We now have to define machine setup 2. And without having a solid model and without moving any of our geometry, we need to make sure that we set this all up correctly. Our copy and pastes and our faces and stuff, because the face does it automatically, might not read correctly. So we're going to go in here and say rename. Actually, it should, because we defined the bottom geometry as the face. So I don't know. I didn't mean to say rename. We're going to go to edit in here. Sorry about that. Right there. And we're just going to pick the origin as this bottom point right here, the top dead center in there. You can pick whatever point you want. Just remember, there's certain things that rely on knowing where that point is. One of them being the toolpath pattern, which we don't really have to add right now unless we wanted to do that to the pocket. But the next thing we need to do is that Z, that blue arrow, always needs to be facing away from your geometry that you're trying to cut. The direction it's pointing in, you're always cutting opposite that, because that's kind of the floor and you're going into it. So we need to fix X or Y. Now, right now, X looks like it's pointing in the right direction. So I want to go right over here to the Y direction box, and these buttons on the end are just to flip the geometry, or just to flip the origin. So I'm going to flip that button right there with the Y, and then I'm going to flip the button for the X. Or if I did that the other way, it would have been like that. If I had just flipped my X, same thing. We got to flip it either way. So X and then Y, or Y and then X doesn't seem to give you a different result. They both need to be flipped. But don't pay attention to the Z. Only pay attention to the X and Y. We have to follow the right-hand rule in BobCAD. So what that means is we can never violate that. So if you get X and Y in the right locations, pointing the right way, Z has to follow that. There's no other way for it to, we can't do a left-hand rule. So there it is. So now we'll go ahead and set up. If you wanted to change work offsets, you could. You know, it wouldn't be a bad idea. Think, you know, if you had specific jaws made for this, and they're taking into account now that the part is 100,000 smaller, you could go in and let's say work offset number 2. So that'll be a G55. So if I was doing a bunch of these parts, or maybe 2 at a time even, maybe I started on one vise, I flip it over and shove it in another vise, and now I'm running 2 ops or 2 parts at the same time, a rough on the top side and a finish on the bottom side, and I'm just switching because we're going to use all the same tools, so it wouldn't be a bad idea to do that. The only other change, again, I'm going to make is add a Z value into my work offset. Again, that's just for my simulation. That does not affect the code. So there you go. Clearance plane's fine. We'll hit OK. Now, with this one, because of when we define the stock, we added the end face and the start face. So it should know how much geometry we have. I was thinking it might look at it based on where it touches geometry from our origin. All we got to remember is we added 100 thousandths. We know where the top of the part is, and we know how we're going to run it. So you could either copy the feature, which is going to have the depth and everything. So we'll say copy. In V34, you also have copy with geometry. And this is helpful if the geometry stays the same. So I'm going to just say copy, or it doesn't. With facing, it doesn't really matter because it automatically finds it. So I'm going to go ahead and paste it there. Now, this is something new to version 34, and if you guys didn't know it, now you'll know it. When you copy and paste it in the past, so version 33 and back, if you copied a feature from machine setup 1 into machine setup 2, and machine setup 2 has G55 or work offset 2 running, the feature that you pasted would always stay as its original work offset. Now it can change that. It'll automatically change that if you want it to. So would you like to update machine setup 2? So basically we want to update the facing feature to match machine setup 2. So we'll go ahead and hit OK. We'll just say yes. And then if we right click on the facing and hit edit to double check that it worked, and just to show you guys, on the posting page of this now pasted toolpath, it's set to number 2. So that's how we got it. So now I can hit compute, and there it is. It looks pretty good. We want to look at the feature page here. Top of features at 0, which is perfect, and the total depth is 100,000. So it is recognizing it based on what you set up as the origin or the extra stock that you have on there. All right, sorry about that. My throat keeps drying out. All right, so we will compute. It's already there, and there we have it. So then I'll shrink that up and blank it out. Now we then want to do our counterboard pocket. So we're going to copy the, actually we'll do the slots first. That's the order we did it before. So we'll copy the slots. And we should be able to copy with geometry because from top side to bottom side, as long as everything's located properly, they should line up. So we will copy those. And then I'm going to paste them. We should be able to do actually copy with geometry. Let's try it. Let's see if everything lines up. So we'll say copy with geometry. Or if you have version 33, just copy it. What if you left these on the bottom of setup 2? So if you're saying, so instead of having the one on the top and this one floating up above the part, it's sitting down there at 0 there, Rick? I would edit machine setup 2. So right click on machine setup 2 and just go to the top, say edit. All those points should pop back up. Are you saying you did it unintentionally or you meant to do that? Because that could be different. You meant to. Then you would have to locate XY on this side of the part and then drop it down to where that Z0 would be. Or if it's locked in from, well, machine setup 1 would have been on top of the part. Well, then, okay, so on your facing, all right, let's see. You'll have different numbers than me. For me, I have 0. And you should have, if you're at the bottom of the part and you'd be up 1.1 inches. So your top of feature for your face would end up being a top of feature at 1.1 inches. And then your total depth would be 0.1 because you're going from that center point at the bottom, you'd be going up 1.1 inches to the top of the part and then taking off your depth of 0.1. And then when you compute that, that should show your face in the right location. Let me know if that is what you meant. I think I got it. Without having a solid model with this, it does get a little bit more difficult. But a quick little button that you guys can learn about real fast, and it pays to know it at least, is the stock when you're inside the stock. So what I'm going to do is over here in my layers, I'm going to add a new layer and call it stock. All right. So if I go over to my stock in the CAM tree now, and I right click and go to the stock wizard, or actually, I don't even have to go there. Sorry. We're going to right click on the machine setup 1 and just say edit. There is an option in here called keep bounding geometry. And what it does is it grabs the wireframe that BobCAD created and it adds it to the part. So I could go in and say origin or keep bounding geometry, cancel out of that. We didn't change anything. And then on that layer, I now have that bounding geometry. Why is my other stuff disappearing? I don't know how that happened. Something got moved. All right, no big deal. I'm just going to, let's make sure this is good. This is good. That's good. And then the base should be all the rest of that. Huh. That's really weird. It grabbed my base somehow, but that's a way to keep it. So now what you'd be able to do, because your origin, is at the bottom of that part, you'd be able to go up and inside your feature right here, you'd be able to go in and say pick top, and then you'd pick that point right there, and then you'd tell it the depth you wanted to go. So definitely doable. Just depends on, how you set your origin up. But really, how you set your origin up is, it's very important. But there's many ways to do it. You could really set it up off whatever you want. Wherever you can locate, you could pretty much mimic that in BobCAD and locate off of it. So let me pick this thing. Am I in a feature or something? What's going on? There we go. There we go. All right, so let me just move this back to my current layer. Then I can hide that stock. There we go. All right, so we have our facing on there. Yep, right there. And then we will now do these slots. So let's do this one. We're going to right click on the slot, say copy with geometry. If you're using version 30, I just said this a minute ago. I cut myself off in this one. If you're using version 33, just copy it and then paste it. All right. And I'll go ahead and paste the feature. And then what you're going to do, well, I'm going to update all my work offsets, but then what you're going to do if you have 33 is right click on the word geometry. There should be a little red plus sign because you guys don't have a copy with geometry. So you'll right click on geometry, say reselect, and then hold shift and pick all 6 of your pockets. And then when you're done, we should be able to, and if this works, let's go look at this. We'll say edit. We're at minus 0.1 for our top of feature and 0.375, exact same cuts on this side. And we'll go ahead and compute that one. And there we have it. There's our slots for that side. Man, it stinks not having a solid model for this. If someone wants to do the solid model, anyone give me a yes. And when we finish this, we'll draw out the solid model real quick. I'm going to do it anyway. Just to show you guys, it's just how easy it is, really. It really won't be too bad. All right, so we're just going to blank out the slots, shrink it up. And the next thing we're going to do is the counter bore, which I have right there. So the counter bore, the C bore there, we're going to copy that guy. Again, we could do it with geometry, or I'm just going to do it like we do it in 33 or 30. Copy it, paste it under machine setup 2. Do you wish to use the same top and depth? No, I'm going to pick it this time. I'll do it myself. So right here, we'd right click on geometry, say reselect. And we're just going to pick that counterboard feature once again. Now, right now, again, what it's doing is it's not accounting for the faced off material. And we have no geometry to pick that. So we have to remember to go and do our minus 0.1. And then we could tell it the total depth, which was 1/8 of an inch. So 0.125. And then we'll hit OK and compute that thing once again. And there it is. Perfect. I'm trying to think here. Yeah, that should do it. I was thinking if there was a cool way to show some stuff off, but never mind. All right, ignore that. So let's go ahead and give that a save. It's been a while. I haven't saved in a while at least. We'll go ahead and shrink that up. And then looking at everything that we have on the part, we got the slots. Yeah, that should be everything. So if you go into and run your simulation at this point, so I'm just going to run the sim. It will flip the part over for you. So we should see the whole thing run and get the results of what the entire job is going to run like. So we'll start it right there. All right, so face off top, center drill, tap, open up that center hole, make our pockets, outsides, and then we're going to flip it over, face it off, make our other pockets, and make our counter bore. So now we have the entire part done. Everything lines up. Looks pretty good. So again, there's still the whole thing with, work holding we have to deal with that I didn't go into, but that's what makes you guys a machinist, right? So let me go ahead and close out of this now. So how would you go and post this out? All right. And this is totally up to you how you do it. And it really, it kind of is up to you, and it depends on your post as well. So the first thing you want to do is make sure you have the right post processor. I'm going to go ahead and just do a post yes, no on the entire jobs for now, just to show how it works with just the facing toolpaths, just because they're short and quick and we can look at them. So from here, I'm just going to post my code by right-clicking on milling job, or you can go up here and hit post. Don't matter how you get there, just get there. And so right here, we'll see we have machine setup 1, G54. Machine setup 2 down here, G55. So the way this post handles it is it puts an M00, it puts an optional stop in the machine for me to flip the part over, which is one way of doing it. Another way of doing it could be what I mentioned a few minutes ago. Maybe we run just machine setup 1 on a single part. So we'd post the code out. This is all the code for machine setup 1. We cut that part. We take that part out. We put it in another vise, and we then would run both of them. At the machine, we would locate G41 off of the first vise we used, G54, and then we would use G55 on the other vise. And you'd post it all out, in which case you'd want to get rid of, well, it's way down in there. You'd want to get rid of that M00. Another way of doing it is you might cut all the tops and then flip it over and cut all the bottoms. That's another way of doing it. And for me, that would just be, you do a post yes, no on, let's start with machine setup 1. So you'd post yes, no, machine setup 1, you'd post it. You'd right click in here and do your save as. We'll call it that. And then we could call this, top, or I'm just going to go op 1. and then we'll say save. And then you would turn that one off, turn machine setup 2 back on, post the code, and then you'd be able to do a save as on that one. And we'll just say op 2, save. And so now you have 2 sets of code that you could bring out, and that's kind of really depends on how it's doing it. Brock, you're not able to post the code. Pushed all the post buttons, but it's not coming up. Is your posting should show up. What machine? Actually, I could see what you're using. You're using the BC3X mill. That's what you were using. Did you ever delete any posts? Do this right here. In your CAM tree, right-click on the post that's just below the BC3X mill. Right-click on that and say Edit. A box should pop up. You're going to hit Select. And it should open to this folder, but if it doesn't, I'll walk you through where the folder is. You're going to go to your C drive here on the left, then to BobCAD-CAM data, and then whatever version you're using, version 33, 34, 32, whatever you got, open up that folder. In that folder, you'll then see one called Posts. We're going to open that one up. In that folder, you'll see the machine type, so we're going to go with mill, and then pick one of the posts out of here, like repick the BC3X mill, and then hit OK, and then try and post again. If that doesn't work, I've had it happen before where you just won't post. Save your work, close BobCAD, open it back up, and try and post. Sometimes it's simple as just restarting the program. Usually happens to me if I let my computer go to sleep. Like when I go to lunch and my computer falls asleep, that's usually what I get. But try those out. If it's still not posting, if it's specifically this part that's not posting, then I'm not sure. All your options might be set to post yes, no. If these little things are lit up right here, or let me go to the classic view, CAM classic, apply, okay. The classic view would be these little icons right here. So next to your features, if you have that little controller with the X on it, that means they're post yes, no. You have to right click and do a post yes, no, just to turn them all back on. And then again, when you post, it should come up. If that doesn't fix it, we'll probably have to look at it, see what's going on, or get in touch with tech support, because that shouldn't happen. Because even on yours that you sent me, other than the changes I made, it's there. So it's either a bad connection with the post or something else. All right. So those are all the kind of different ways you'd be able to post that one. Now what I want to do, and it'll be pretty quick, is I want to make the solid for this. I figure I'm not going to wait. Let's put this all into one thing. It's still 2-axis cutting. It's just a little more 3D geometry, but it'll let me, you guys will see how much easier it could potentially be to make this part. So the first thing I want to do is I want to make a layer and call it solid. Whoops. But I also want to make another layer, and I'm going to call this layer bottom. And this is just going to be the geometry that has to cut through the bottom. All right. And so the way I'm going to set this up for the bottom pieces of geometry is with a translate. I'm going to go to Utilities and Translate. And you got to think of it from the view we're working in. I'm going to go to my isometric view here, like so. So this is the top of the part. So from here, we're going to go down 1 inch. So all we're going to do is grab all of this geometry right here. Grab it. That one, that one, that one, and that one. And then we're going to drop it down in Z. We're just say -1. Make sure that you turn on the copies button. That's the most important thing here. And then we can hit OK and cancel out. So now what we're going to do is we're going to turn off the layers that we don't need. Now, even with a translate, the geometry that you translate, it doesn't go to the bottom layer. I just didn't want it in the same places where I'm working. So we're going to turn off everything that doesn't go all the way through the part. So for this one, it'll just be the slots and it'll just be the counter bore. All of that is going to just get extruded to 1 inch. So we'll go up to Create 3D. We'll do an extrude curve, and we're just going to drag a box over all of our geometry. Now, by default, it goes up 1 inch. That's just where it sets it up. But if we put a 0 in for the distance going up, and we hit Tab or we click in another box, BobCAD will always enter a 1 into the other box. So if we 0 this one out, the 1 goes back to the top. So I want to 0 that out. There's my 1 inch down. I'll then hit OK and cancel out. So that has all the holes in it that we need it to have. So now we could turn our other layers back on. So there's our slots. There's our counter bore. Now, if we flip this part over, we'll see because we translated the stuff down, it also pops up on there when we do that. So now we're going to go in and just pick the top slots and cut them in 3/8 of an inch. So we'll go ahead and just say extrude cut. I'm going to click in the window. So this is big. For shortcuts to work, and you guys might run into this sometimes when you try and change just something as simple as your view. If the drawing window isn't your active, kind of the last click you made, some shortcuts don't work. So you need to make sure to just left click in this window and then hit the letter S on your keyboard. And that'll hide the shaded surfaces. And that allows you to then kind of get in there and grab that geometry. Because if that surface is there, BobCAD finds that surface. If you hide the surface, it grabs that line. So I'm just going to hold shift and pick all of these right here. Now, the distance that it's going up, I grabbed 2 of the wrong ones, didn't I? Yes, I did. That's the thing I was worried about doing. There we go. There and there. Did I do it with more than one? Yeah, I totally did. Did it with a bunch of them. All right, so there we go. So notice that it's going up 1 inch right now. We need it to go down 3/8 of an inch. But if we think about this now, we also need to do the same thing on the other side. But for the numbers here in BobCAD, they're going to be opposite. So the distance going up right now is irrelevant. It doesn't touch another solid model. It doesn't even touch the solid model we have. So it doesn't hurt anything if you do leave it up. So what I do when I'm doing a part like this where I got to go 3/8 deep is I set both the distances to 3/8. So now we're going up 0.375 and we're cutting into the part 0.375. Now, why is that important? Because when we do these bottom shapes, that 0.375 isn't going to be going down, it's going to be going up. So it just saves us a second. So go ahead and hit OK. And then if you want to hit the letter S on the keyboard, again, click in here and hit the letter S. There's the first set of cutouts. Then I'm going to make sure to pick the bottom ones this time, which I can actually hide the geometry for and drag a, I can't drag a box. Never mind, I can't drag a box. I'm just going to hold shift and pick all these. Just try to make sure I get the right ones. Putting them on a different layer wouldn't be a bad idea. We'll go ahead and hit OK. Cancel out. And now when we hit the letter S once again to turn it back on, we got those pockets getting cut in on both sides. And then finally, the last bit is just using the counter bore. And I would hide the slots. I would hide the base. And honestly, I would hide the bottom. But I've been putting my whole solid on the bottom. So I need to go to my select mode. I'm going to grab it. I'm going to pick the solid and then put my check mark on it. And I just want to use that modify to current layer. That way I can hide the solid. All right, so the last counter bore we have to do to make this thing a solid model is we're going to go ahead and do another extrude cut. The distance up is going to be 1/8 of an inch. The distance down is going to be 1/8 of an inch. That way I don't have to change those numbers again later on. And even with the layer hidden, just so you guys are aware, BobCAD doesn't care that the solid is on the layer. It cares about the fact that that solid that we're creating right now will intersect with that solid even though it's on another layer. If you wanted to add these two things together instead of subtracting, you'd do something like an extrude boss. We're going to subtract it, which is just an extrusion with a Boolean. So with our solid layer turned off, I'm just going to hit OK, pick the other piece of geometry, and hit OK. Now, like I said, even though it's on a hidden layer, it does still affect the part. So you can see there is the fully drawn part. Now, why would you ever go about doing this, especially after you've programmed the entire part? You wouldn't. You wouldn't. You would do this before you started programming, and it would make programming easier, because now when I go to do my holes, all right, I'll do it as a new feature. I'll just go to my mill tap hole. Now when I go to do my holes, instead of picking just arcs, I can go and pick the surfaces, just like so, and hit OK. And then right there, it knows the diameter, it knows the depth. When we go to the next page, it knows where the top of feature is. Now, we would still have to account for the fact that there's the 100,000ths on the other side, like we talked about when we did this, but I didn't have to think about any of that. Having a solid model saves a lot of time. It's all you need. It's what you need when you're doing 3-axis, but for 2-axis, it is still very important. We're coming out with a new, we're calling it Launchpad. It's basically online courses for you guys to learn. And it's nice because you don't have to wait for anyone. You could do it at 2 o'clock in the morning if you wanted to. It's all going to be online. I'm working on 10 courses right now. And hopefully it'll be launching before the end of the year for sure. I'm hoping. We'll find out. But it goes through this. Now, it does have some 3-axis examples, but it's going to have about 5 2-axis examples where we go from drawing out the basic shape, drawing the shape, then turning it into a solid, and then machining it. Because though we don't need the solid, when it comes to machining the solid, it is so much faster to have a solid. It saves us a lot of time. Because one thing we could do now that we have a solid for like the pockets, the slots that we have, I can remove all the geometry and I could go and just pick the floors. I say, I want to machine all that right there. Knows the top, knows the depth, has all that figured out. I hit OK. We're going to get the exact same result here. But it's done. And all I had to do was click on some pockets. Where it really gets good is copy and pasting, because you can go in and just pick it. There's also, let me see if I have it. Let me grab the C-bore here. Or actually, which one? We did the center through hole. The center through hole we used the high-speed adaptive on. All right, so I know it's got an advanced pocket attached to it. So I'm going to copy that one, and I'm just going to go ahead and paste it. And now what I'm going to do with this, I want to use the same top, and no, I don't actually. So this is going to be the C-bore. Once again, let me rename this guy. 2. All right. So the geometry for this, I can go in and use this feature. It's called Detect Open Edges. So this is, if you guys have ever done open pocketing in the past, the way that you do open pocketing in BobCAD in the past was to use a dotted line. So if there was an area on your part that the tool was allowed to leave on, you would use a dotted line. But with this one, it reads these 2 chains. Let me get my top of part and my total depth, just like that, and I'll hit OK. Now I can compute that tool path, and we'll see what it comes out looking like. I'm pretty sure this should work. And there it is. So you have your pocket. Let me blank this. Oh, let me go back to my normal cam tree. I hate not having these buttons anymore. User interface, cam, classic, extended, right icons. Yes, apply. Okay. So now I could blank this out and look at, there is my pocket for that. So the normal counter bore was this spiral we have here. Let me just edit this real quick. What's our step over on this guy? 20% step over. This one is going much further. So let's go to 20%. And we'll just recompute that real quick. So we probably won't notice too much of a time savings here. But if we look, this counter bore is going to take 8.9 seconds and 8.7 seconds. It's not much when we're going, how fast are we moving right now? Let's see. So the pocket's going, let's say this is going 50 inches a minute. This will be a little bit better for us. We'll say 25 there. All right, so the pocket's going there. Pocket's going to go 50 and and 25. Apply. Yeah, okay. All right, so that's more like it. It's still only about a second. What's this toolpath even look like? Oh yeah, okay, so that is it. So you'll notice with this one, and it's still really fast, but it's about 7 seconds worth of cutting because it's starting in the middle and it's spiraling out from there. If we look at this other one, which doesn't start, I mean, it still starts in the middle. It plunges in the middle, but then it feeds over. Whoops, that's the whole time. It's 1.9 seconds to 7 seconds. And that's because this second pocket that we're doing, why is this showing the whole time? Blank you out. Blank you out. The second pocket we're doing isn't cutting the inside. It's just going in and cutting that area. It detected the open pocket. It knows that that's an open edge without us having to go and extract the edges off the pocket or draw them out and then convert that wireframe piece of geometry. This, it'd be the base actually. We'd have to take that arc right there and make it a dotted line. And then it would know in the past, if you're using version 333, that's how you'll have to do it. That's how it knows that you're doing the open pocket. So detect open edges, it's a killer feature. You just pick the surfaces, but it all relies on you having those surfaces. But with that, you'd also be able to skip a lot of this stuff, like the feature mill hole that we did it, all in one. I could go in and do hole recognition. And not only could I do hole recognition, but when I created those holes, the way I should have created those holes was I should have used the advanced holes option when I did it, because then you can apply attributes to the hole. So the hole itself would be, when BobCAD reads it, knows that it is a threaded 1/4-20 hole. So there's a lot you could do with that. Play around with it. Like I said, we'll be releasing that new training stuff hopefully before the end of the year is my goal. And it'll walk through a few more examples of doing stuff like this, but you guys will be able to do them at your own time. So there we go. I didn't really plan much more than this. I thought this was going to take a little longer. But I'm here to answer questions. If you guys have any questions, let me know. I'll be here for a little while, probably at least a half hour, just waiting for you guys if you run into anything. If you didn't finish the part or you want a copy of this part file, let me know in the questions box. Just say I want it, and I will resend it to you. I'll save it right now. I'll do save as, just for those of you guys that have it. If you want it again, this will be end. Whoops, I'll do that in caps. There we go. End. And then save. So if anyone does want it, let me know. Otherwise, if you guys have any questions, put them in there. If you don't have any questions, have a good day. We're going to be back on Thursday, but it's for BobCAM for SolidWorks, not BobCAD-CAM. So it's our SolidWorks plugin that we have. But if you guys have it, join it. It's covering lathe. And then be on the lookout soon for some updates on this new Launchpad learning management system. It's going to be like online courses. You may have done some in the past. Pretty swift. So thanks, guys.